Okay, cerebellar gross anatomy. I'm going to start here on the left-hand side of the page, and this is just the sagittal section. And I'm going to start labeling. This is a part of the brainstem that is uppermost, so this is going to be your midbrain, right? And then the next section down of the brainstem, this one's going to be your pons. And then here's your medulla. And then all the way down is going to be your spinal cord. So hopefully those are very familiar looking to you at this point, having gone through. And this big area back here is going to be your cerebellum. Thinking about the cerebellar gross anatomy, what we're going to draw is what you would identify if you just pulled the cerebellum from a person's brain. So way back when they were doing dissections in neuroscience or medicine or whatever, they pulled the cerebellum out of the brain cavity, and then they labeled the different parts that they saw. And that's all this is. Okay, so there are just some very specific words that you need to be aware of. Okay, 3 different parts for cerebellar gross anatomy. Okay, just what you see when you look. Right back here, and it's actually behind the pons, and it's kind of tucked away back behind the brainstem. There's going to be this area here, which I'll show in red. Okay, that area has a very specific name. I don't know who named it, but this is called the flocculo-nodular lobe. Flocculo-nodular. Flocculo-nodular lobe. Okay, and that's nothing more than cerebellar gross anatomy. You will see the flocculo-nodular lobe ordinarily when we look at the other spaces, but you can't see it unless you do a sagittal section because it's tucked in behind the brainstem. Okay. And moving on, so that's your flocculo-nodular lobe. You also have this little indent here is a nice separation point. This area on the top. Okay, this whole area that I'm showing here in blue. Okay, that's known as your anterior lobe. So these are just basic parts of the cerebellum, and this is the anterior lobe. So if I looked at the cerebellum proper, I would see just a small demarcation, and that small demarcation, anything above that, if I'm looking at the back side of the cerebellum, I'd call that the anterior lobe. And then on the bottom here, this region below that little indent, as far as gross anatomy is concerned, it is your posterior lobe. So gross anatomy, you have your flocculo-nodular lobe, you have your anterior lobe, and then you have your posterior lobe. And all the cerebellum, most of it just sits behind the pons. Remember, they develop from the same embryonic region. Moving over, now we're going to look at the topmost picture here. Okay, the topmost picture, if I had to draw in, this is a large white matter conjugate. Large white matter corridor, how's that? Okay, large white matter corridor that is going to connect the pons with the cerebellum. Here's where white matter is going to go through. These two are both known as middle cerebellar peduncles. Okay? White matter, remember we talked about all the different names for white matter? Peduncle is one of them. So those are just going to be a highway region for axons to go into the cerebellum. Yes?
So you said it connects the pons and the cerebellum.
Yeah, and we're going to see, there's 3 different regions, but this one specifically, if you're talking about cerebellar gross anatomy, middle cerebellar peduncle, it's going to be one of the ways that information travels in to the cerebellum from the pons, specifically the pons region. There's lots of information. And then we have the flocculonodular lobe. So here, this picture, if I just take away the brainstem completely, and I take this and I flip it up, this is what I'd see. So in other words, it's like this here, and then when I get to this picture over here, I just flipped it up. So if you can imagine those middle cerebellar peduncles being here up top as a conduit across right to the pons. So when I flip it up, this is what I see. Okay, does that make sense? See where I am? Just took this piece and I'm flipping it up. So these are the connectors. So if I take this piece and flip it up, now I have to represent my flocculonodular lobe in there, in the middle, right here. Okay, that's going to be my flocculonodular lobe. Many years ago, I've been teaching this part for a long time, I don't even know how many years, but remember doing this for the first time, and I was saying that this red, this flocculonodular lobe that's right here, kind of reminded me of those airplane wings that you get when you're a kid and you travel on an airline. Do they still give those out where you get little wings? They don't do that. Okay, well, that's why nobody knew what I was saying. And I had one person in the front of the room raise her hand and said, I know what that looks like. You know what she said? Penguin of Madagascar. Right? You see it? So there you go. So the penguin of Madagascar. So if you think about cerebellum, think of the penguin of Madagascar. Penguins. Okay. Now, flocculonodular lobe here in the middle, tucked in away behind the brainstem. And then you have your anterior lobe, which is going to be the top portion. That's all anterior lobe, shown in blue. Okay, and the anterior lobe's up top, so that means posterior lobe's down below. So this portion down here, just basic gross anatomy, this is your posterior lobe for your cerebellum. Green is just your posterior lobe. Everybody got it? So this is going to be, if you took this brainstem away and you took this piece and flipped it up and just looked straight down, this is what you'd see. And there's one more view that this is probably going to be the most common view that you see in textbooks. It's going to be down here. And what this represents is the view of the cerebellum from behind. So in other words, if I were looking at the cerebellum from this direction, this is what I'd see. And because of that, most textbooks, for whatever reason, are going to choose to represent the flocculonodular lobe, which you can't see if you're looking from behind. they're just going to take it and roll it down and then represent it here on the bottom. Okay. So starting out, you can just see that this is going to be your flocculonodular lobe, and they put it below because you can't see it from behind. Okay. So here's your flocculonodular lobe. And then what you see if you look from behind here, on top, you're going to have your anterior lobe. Okay, and on the bottom, you're going to have your posterior lobe. So, nothing tricky. 3 main lobes, anterior lobes on top, posterior lobes down the bottom, and then tucked away in the middle is your flocculonodular lobe. Again, these are just basic names of these regions. By looking at just, if you had a cerebellum and you're holding it in your hand, you can see these basic regions of the cerebellum. These are what they're called. Questions about gross anatomy of the cerebellum? Yes?
Is it, you know how like the brainstem is when like all the rostral caudal like to the dog standing up? Is that why the anterior lobe is looking like superior? Does that make sense?
Yeah. So yeah, below the level of the midbrain, so that would be anterior and posterior, and yes. Because below the level of the midbrain, you've got your, well, the landmark is your red nucleus, which we're talking about there. After that, it's kind of flip up.
Okay, thank you.
Any other questions? Again, this is just basic gross anatomy, nothing fancy here. The next one that we're going to look at is the cerebellar functional regions and nuclei. So this is the next step up from just doing the dissection and pulling out the cerebellum. Okay, this is when people actually figured out that different parts of the cerebellum had different functions and did different things. Kind of like if you think about the frontal lobe of the cortical region being involved in motor function. Well, this is which part of the cerebellum is actually involved in doing what. That make sense? So this is the next step up. So these are going to be the cerebellar functional regions and the nuclei. Okay. On the left here, start over here on the left, this picture. Okay, and again, this is a flocculonodular lobe. Most textbooks are going to have you looking straight from the back, so you don't see that, so they roll it down below. And on the left side here, I'm going to choose to represent the functional regions of the cerebellum. Okay, and on the right, we'll do something else. All right, we're going to look at the nuclei that are associated with each of these functional regions. Looking at, start on the left side with the functional regions. Probably the easiest one to do is this guy down here. So as gross anatomy, calls this the flocculonodular region of the cerebellum. Okay, so it's the flocculonodular lobe, but it also, its function, type in. Okay, but really the functional region of this is known as the vestibulocerebellum. Okay, so this as a functional region is known as the vestibulocerebellum. So the flocculonodular lobe itself has the function associated with vestibulocerebellum. knowing that it's vestibulocerebellum, does anyone have a guess as to what it controls?
Balance.
Balance. Right. So it's going to be vestibulocerebellum is going to be associated with balance. So if somebody had a stroke or some sort of problem in their cerebellum, and you know it's going to be specifically in the area of the flocculonodular lobe, you would expect that person to have problems with balance. Okay, because the vestibular system is intimately connected with this region, and we're going to draw that pathway toward the end. Make sense? Yeah. Now we also have the region again over here on this side. If you look, it looks like this is almost like the spine of a book, if you want to imagine. So we can go ahead and delineate that region of the cerebellum here, just with some dots. And this region of the cerebellum is going to be the very middle, and it has a special name, and it's called the vermis. V-E-R-M-I-S. The very middle is known as the vermis of the cerebellum. And all that region in the very middle, bilaterally, is called the vermis, right in the middle. Okay. And its role in life is to receive information about non-conscious proprioception from the trunk, only the trunk. So axial musculature, trunk muscles. Okay, so the vermis is responsible for receiving information about non-conscious proprioception. That means knowing where your trunk is in three-dimensional space without even thinking about it. It's constantly receiving that information. Okay, and that's going to be received by the area of the cerebellum known as the vermis. Okay, just outside, what do we have? Let's say, let's do this color. Okay, just outside the vermis or the vermal region, you're going to have the next area. It's not quite fully lateral yet, and this next area is known as the paravermal. So these two regions right here are paravermal. Okay, these are your paravermal regions. Okay, your paravermal regions are responsible for receiving non-conscious proprioception from extremity muscles. Okay, so the vermal region receives information about non-conscious proprioception coming from your trunk. Paravermal region receives information about non-conscious proprioception coming from extremities. So each part of the cerebellum has its own function, its own piece of information that it's receiving from the rest of the body. Okay, the last region we have here is going to be in the very end. Okay, and these are going to be your lateral hemispheres. Okay, and your lateral hemispheres are known as your cerebellum. With a name like cerebellum, what do you think they're involved with? Cerebrum, yeah, they have something to do with cerebrum. Okay, so the cerebrum is going to be involved in, cerebrocerebellum is thinking about moving or planning complex, here you go, thinking about moving. If you think cerebro, you think brain, right? So thinking about moving. Okay, and the complex motor task coordination. Okay, so your cerebrocerebellum is that conscious decision about moving or thinking about moving. Yes, Gabby, did you have a question? I'm sorry, you said a little louder, I couldn't hear you. Okay, so Gabby's question is, keep in mind the tracks and stuff, and what we're going to do is, this is the very beginning, so we're going to add the tracks in at the end of the talk. Okay, so the tracks are all going to come back to haunt you, don't worry. They'll be here. But this is what you need to know. So thinking about that, so that, that's another thing. So when we talked about all those tracks, all those tracks that we talked about previously in the spinal cord, if you remember the dorsal and ventral spinal cerebellar tracts, they're receiving information about non-conscious proprioception from extremities and trunk musculature. So this region, the paravermis and the vermis combined, make up one big region, and that region of the spinal of the cerebellum is known as so this is to represent that I'm encompassing all the vermis and the paravermal area. This is known as your spinocerebellar region. Okay, so that spinocerebellar region is responsible for receiving that non-conscious proprioception from both trunk and extremities. And if you think about what we covered in the spinal cord so far, you should be thinking that they receive that information via the dorsal and spinocerebellar tract. That makes sense, everybody? Right now we're just talking about functional regions of the cerebellum, what kind of information they're going to receive. So this flocculonodular lobe, or the vestibulocerebellum, mostly concerned about balance. Okay, it's going to receive most of its information from the vestibular nucleus that we've talked about, and the spinocerebellar region, receiving information from non-conscious proprioception. That's going to receive information from dorsal and spinal cerebellar tracts, and then this cerebrocerebellum is going to receive information from motor planning area, the frontal lobe. Okay, we'll get there. We'll go through each of those in turn, but that's sort of a quick preview in case you had other questions. Other questions for me? Does that make sense? Okay, these are the functional regions that you need to know about. And so to be clear, spinocerebellar region is one, the cerebrocerebellar region is another, and the vestibulocerebellum is the third. Okay, 3 different functional regions that we need to know. Okay, thinking about, okay. So all I'm going to do over here, these are the functional regions, and then on this side, I'm going to start listing the nuclei. Each functional region of the cerebellum is associated with a distinct nucleus. Okay, so we can start out with the flocculonodular lobe. There's the flocculonodular lobe down here. Okay, and then we can put in here's our delineation for the vermis. Okay. And then we have a delineation for the paravermal region. Right. Now, both the vermis and the flocculonodular lobe are associated with a nucleus that is known as the fastigial nucleus. Okay, all these nuclei are bilateral. Okay, so I'll represent that. So vestigial nucleus resides in the vermis. It's associated, it is responsible for handling information coming to it from the vermis, and it also handles information coming to it from the flocculonodular lobe. Okay, these are the vestigial, F-A-S-T-I-G-I-A-L, nucleus, or nuclei. Vestigial nucleus. Okay, vestigial nucleus is associated with the vermal region, as well as the vestibulocerebellar region. Okay. Moving over, we also have, I think I did, okay, associated with, since I did this, associated with this paravermal region, there's nuclei. There are really two that go together, but we're going to call them jointly by one name. Okay, these nuclei present on both sides are responsible for handling incoming information into the paravermal region, and as the pair, we're going to call them interposed nuclei. Okay, those are your interposed nuclei. And again, interposed nuclei are going to be responsible for handling information coming into the paravermal region, which is going to be your non-conscious information coming from extremities.
What's
Yep.
it called again?
Interposed. I-N-T-E-R-P-O-S-E-D. Says paranuclei that work together, so we're just going to call them one thing, the interposed nuclei. And then finally we have one last set of nuclei to worry about, and these are the nuclei that are associated or handling information in the cerebellum portion of cerebellum. And these are my favorite. They kind of look like teeth. You know, if you took a cross section through the cerebellum and you were looking for these nuclei, you actually see them, and they look kind of like teeth. See, like a half a set of dentures there? So half a set of dentures have a very specific name. They're called dentate nuclei. Dentures, dentate, D-E-N-T-A-T-E, nuclei. Dentate nuclei are going to be responsible for information coming in to the lateral hemispheres of the cerebellum, or information traveling in the cerebrocerebellar pathway. Questions? Yes.
Is the cerebrocerebellar region just a pathway, or is it
The cerebrocerebellar region is located in the lateral hemispheres of the cerebellum. The cerebrocerebellum is also a pathway that we're going to talk about that connects to that region of the cerebellum. Right now we're just doing the great big overview stuff. Any other questions? Okay. Next thing we're going to talk about is fibers and Purkinje cells. This should actually be P-U-R, it's kind of cut off a little bit. It's P-U-R-K-I-N-J-E, Purkinje cells. Okay, going back. Quick review. Midbrain. Pons. Medulla. Cerebellum. Okay. first slide I talked in the functional regions of the cerebellum, or the gross anatomy regions of the cerebellum. I talked about this thing that was a major conduit or a major area where axons cross information from the pons into the cerebellum. Anybody remember what the name of that is? The middle something.
Middle cerebellar.
Peduncle. Good. Middle cerebellar peduncle. Okay, so there's your middle cerebellar peduncle. Again, this is just a sagittal section. You're looking at, there are actually 3 major conduits that you can see in this sagittal section. This one here in the middle is the middle cerebellar peduncle. This one here on the top is the superior cerebellar peduncle. And that leaves this guy here on the bottom. Any guesses? Inferior cerebellar peduncle. Okay. Other pieces that we can draw in that we've talked about already, there's going to be deep cerebellar nuclei. Those are the nuclei that we just talked about. And just for the purpose of demonstration, this is kind of like a big picture concept, I'm just going to draw in a generic deep cerebellar nucleus. It can be anyone. It could be fastigial, could be interposed, could be dentate. We're just going to represent this blue circle as a deep cerebellar nucleus. And it could be any of them. This is just for illustrative purposes. This is any of the deep cerebellar nuclei. And you should also know this new word, this Purkinje cell thing. It's going to be a main connector to the deep cerebellar nucleus. And these Purkinje cells they're all throughout the cerebellum. They're found in all areas, and all areas of the cerebellum are associated with their own deep cerebellar nucleus. So if I represent this Purkinje cell, to me it looks kind of like an onion shape, sort of like that. Okay, and this Purkinje cell is always associated with its region's deep cerebellar nucleus. The connection is always there. So this is going to be your Purkinje cell. The Purkinje cell is nothing more than the area that the rest of the body or all these pathways are going to use, or the kind of cell that these pathways are going to use to convey information to the deep cerebellar nucleus from that particular region. Does that make sense? I think as we go through, maybe it'll become a little bit more clear. There's one more important player here. Does anybody remember, if this is your medulla, I talked about there being 2 bumps. There's like a more medial and then a more lateral bump. Does anybody remember the name of the more medial bump, which would be here? It's where the corticospinal tract crosses.
Pyramids.
Yeah, these are your pyramids. Good. And they're named the pyramids because that's where your pyramidal tract crosses over. Now there's something really important, I think I mentioned it previously, that resides here in the second bump, the more lateral bump. Does anybody? Olive, yeah. That's called your olive. And then specifically, it houses something specific kind of nucleus. It's really really important for motor learning. It's known as your inferior olivary nucleus. to your inferior olivary nucleus. It's going to be really important for motor learning. We'll see why here in a minute. Okay. Coming into the cerebellum, we're going to see all these pathways here in a minute. But coming into the cerebellum, anytime one of these pathways or these axons travel mostly through the inferior cerebellar peduncle, sometimes through the middle, and sometimes through the superior. So here we have information coming down from the cerebrum. It's going to travel through the inferior cerebellar peduncle or the middle cerebellar peduncle. It's going to contact Purkinje cell. Okay. Then we're going to see other axons that come in. They're going to come in from the spinal cord, and they're going to travel all the way up and then enter into the superior cerebellar peduncle and then make contact with the Purkinje cell. And then we're going to look at another pathway that comes in and travels up the spinal cord, enters through the inferior cerebellar peduncle, and makes contact with that Purkinje cell. Okay, these are the three different pathways we're going to look at today, but the important part here is that every time there's axons coming in through the inferior, middle, or superior cerebellar peduncle, they're coming in and they're going to make contact only with that Purkinje cell. Okay, they make contact with the Purkinje cell, and it's the Purkinje cell's job to get all this information together and deliver it to the deep cerebellar nucleus. Everybody see that? All these generic fibers that are coming from three different pathways that we're going to see here in a minute have a special name. These are all called MOSSY, M-O-S-S-Y fibers. They're all called MOSSY fibers. So that just means these are axons that are coming in to the cerebellum to make contact with a Purkinje cell associated with their region. Okay, so MOSSY fibers are just axons coming into the cerebellum. The only other kind of fiber that you need to be aware of are fibers coming from this inferior olivary nucleus, right here. Okay, the inferior olivary nucleus comes in and contacts the Purkinje cell. So this nucleus, in other words, has access to all the information coming in from the rest of the body to that Purkinje cell. So it knows what information was received. Not only that, it also makes contact with all the deep cerebellar nuclei, and the deep cerebellar nuclei are responsible for making a decision about what to do with that information or how movement should proceed or stop. So this inferior olivary nucleus not only knows what came into the system, it knows what the cerebellum decided to do with that movement or what went out. So not only is all this afferent information coming into the Purkinje cell, the inferior olivary nucleus also has that afferent information, efferent information coming from the deep cerebellar nucleus and then going out to the rest of the body is also perceived by the inferior olivary nucleus. And because of that, the inferior olivary nucleus can make adjustments or help make adjustments for motor learning. Think about conflict. Yes, Johnny?
You said all information, period, goes, the inferior olivary nucleus knows any information that's coming in or only from the spinal cord?
No, it knows all the information. So any information that's coming into the system, and we're going to see that information is going to be mostly from the vestibular nucleus, from the dorsal and spinal cerebellar tracts coming up from the spinal cord, as well as the motor planning areas in the cortex. Okay, so all that information is coming in and put into the Purkinje cell. Purkinje cell transfers that information to its deep cerebellar nucleus, and that nucleus has to decide what to do. What's the output? Do I want to move or not? And then it sends that information on.
So since you didn't draw those like axons, the MOSSY fibers, like going straight through the nucleus, are we
but all go through the Purkinje cell. They don't, the mossy fibers do not make contact with the deep cerebellar nucleus. The only thing that makes contact with the deep cerebellar nucleus is going to be your Purkinje fiber, your Purkinje cell, and your inferior olivary nucleus. That's why the inferior olivary nucleus can help with complex motor tasks, help learn. Yes.
So when you say help with complex tasks, does that mean that it's just like it helps through making adjustments, not through like telling it what to do?
Correct. It helps making adjustments. So think about a toddler learning to walk. Hard, right? Really hard. And then eventually, you grow up and that's where you are. That's the motor learning. Motor learning is a procedural thing. You get it by practice, and the inferior olivary nucleus helps make those adjustments because it knows what was received, and then it knows what was put out, and it also was successful. Was the movement successful? Think about the first time you learned to shoot free throw, or play basketball, or anything that requires coordination, even catching a ball. Right? All that's motor learning. You get motor learning. You'll have motor learning next year in neuro rehab with me, and that's procedural learning where you learn by doing. There's no brain function involved. It's all just do it, and then that motor program is stored in your cerebellum. Does that make sense? So think about how all this comes together. Any other questions? I think that was it. Okay, let's take a 10-minute break.